Hello, good morning. I, SEEMA GARG, Associate Professor in Chemistry, SPC Government College, Ajmer. Today, video 145. It is for B.Sc Part 1, Organic Chemistry, Paper 2, Unit 1. Hyperconjugation. Barker, Nathan, or no bond resonance. Hyperconjugation is extension of resonance effect. The resonance effect involves delocalization of pi electrons of two or more conjugated double bonds or pi electrons of double bond and non-bonding electrons of a heteroatom, whereas hyperconjugation involves sigma electrons, that is a carbon hydrogen or carbon carbon, for delocalization with an adjacent empty or partially filled non-bonding pi orbital or anti-bonding p orbital to give extended molecular orbital that increases the stability of the system. See here how this sigma pi conjugation, it is a orbital representation of hyperconjugation of sigma pi conjugation. For example, propene. In propene, here sigma bond, it is conjugated with this double bond, means pi bond. So it will give hyperconjugation and it is stabilized by this hyperconjugation electrons. In above example of propene, hyperconjugation occurs through the H atoms present on the carbon atom next to the double bond, that is alpha hydrogen atoms. Naturally, more the number of such alpha hydrogen atoms, more are the number of hyperconjugation structures. And hence greater is the inductive effect. Thus, the order of hyperconjugation effect decreases in the following order. It is methyl, which having 3 alpha hydrogen, ethyl, it having 2 alpha hydrogen, isopropyl, it having 1 alpha hydrogen, whereas this tertiary butyl, it does not have any alpha hydrogen. Significance of hyperconjugation. Hyperconjugation is weaker in compared to resonance effect. However, it helps to explain following physical and chemical properties. Directing influence of alkyl groups. The orthopara directing influence of methyl and other alkyl groups can be explained on the basis of hyperconjugation. See here. In toluene, it having +6 more such structures due to other alpha hydrogen atoms. So there are a number of resonating structures due to the alpha hydrogen. Bond length. Hyperconjugation, like conjugation and resonance, also affects bond length. See here how it changes its bond length. Single bond length, it decreases, and double bond length is increases. Dipole moment. Since hyperconjugation causes the development of charges, it also affects the dipole moment in the molecule. Formaldehyde. Stability of carbonium ions. Greater the number of hydrogen atoms present on the carbon atoms alpha 2 on saturation, more are the resonating forms possible due to hyperconjugation, and thus greater is the stability of carbonium ions. Tertiary, secondary, and primary. Heat of hydrogenation. Unsaturated double bond, that is alkene type. If it is hydrogenated with hydrogen molecule, it will evolve energy. Lesser the heat of hydrogenation, lesser the internal energy, and more is the stability of the molecule. That is hyperconjugation. Next, let's calculate formal charge of intermediate and other ionic species. Central atom is surrounded by two types of electron pairs, shared pairs and lone pairs. Shared pairs are also called bonding electrons, while lone pairs are called non-bonding electrons. The average number of electrons on the central atom depends upon the number of bonding and non-bonding electrons around it. So this is the formal charge on an atom. It can be calculated. Group number of atoms minus number of unpaired electron plus 1/2 number of paired electrons. For example, formal charge of hydrogen in hydrogen molecule. See here. Hydrogen, it is in group number 1. So 1 minus 0 plus it having 2 electrons, bonding electrons. So 1/2 multiplied with 2, its charge will be 0. Similarly, formal charge of nitrogen, oxygen and chlorine respectively is 0. Formal charge of carbon in methane, see here, it's 4, its group number is 4 minus 0 plus 1/2 paired electron. Unpaired is 0 and paired are 8. So 4 minus 4 equal to 0. Formal charge in methyl carbocation, see here, it is paired electrons are 6, group number 4, unpaired 0, so its charge will be +1. Formal charge in methyl free radical, see here. In methyl free radical, 4 is a group number, unpaired electron 1 plus 1/2 6 paired electron, it's 0. Formal charge in methyl carbanion, see here, group number 4 minus 2 paired unpaired electrons plus 1/2 paired electrons, 6. So it will come -1. So in methyl carbanion, there is charge -1. Formal charge on carbon of methylene carbene, see here, 4 minus 1/2 number of bonding electrons, number of non-bonding electrons. So 4 minus this will come 0. Formal charge on nitrogen of nitrene, see here, 5, group number 5 of nitrogen, number of non-bonding electrons 4, bonding electrons are 2, so it will come 5 minus 5, 0. Formal charge of nitrogen in ammonia, Group number of nitrogen 5, bonding electrons 6, non-bonding electron 2. So formal charge of nitrogen in ammonia is 0. Formal charge of carbon in nitrile, formal charge 4 is carbon group number minus 2 non-bonding electrons and 6 are bonding electrons. So it is minus 1. Formal charge of nitronium ion on nitrogen of nitronium ion. So it is when we will calculate, it will come minus 5 minus 4 is equal to plus 1. See here, formal charge on each oxygen of nitronium ion. So 6 group number 6 minus 4, 1 half 4 here. So 4 are unpaired and 4 are paired. Here we are calculating about the oxygen. Here oxygen 4 are each oxygen. So it is unpaired 4 and paired are 4. So 6 minus 6 is equal to 0. See here. So this is about today's lecture.